Today we're looking at Glencoe Accelerated Math Lesson 9-6, which is on solving systems of equations by graphing. So the first thing we have to figure out is, what is a system of equations? Systems of equations. Systems of equations means that we have two equations and we're trying to find one solution that works for both instances. So we need to find one x value, one y value, that when we put them into each equation, the statements are true. We can do that algebraically. We can also do that using graphing. Today we're going to do that by graphing. So what we're looking for today, when we graph our equations, is the intersection of the two lines. So wherever those lines cross, that will be our solution. And we're going to write our solution as an ordered pair. Who can remind me, how do we write an ordered pair? Yes, ma'am.
X value first and y value.
Okay, so we have an x value, a comma, a y value. Do we put anything around them?
Parentheses.
Parentheses, very good. So when we write our solution will be written in a set of parentheses with our x value, comma, our y value. All right? Now, sometimes our questions are going to be nice and pretty, meaning that they'll be given to us in y-intercept form. Somebody remind me, what is y-intercept form? What does that look like? What would an equation written in y-intercept, in slope-intercept form, what would that look like? Yes.
Wouldn't it have to pass through the y axis?
It will, but if I'm looking for something written in slope-intercept form, what format is that equation going to be in?
Y on the left side.
Okay, so it would be really nice if we had y equals, and what came after that?
The slope.
The slope, which we use variable
X.
almost.
M.
And then what?
The intercept.
The y-intercept, which variable did we use to represent the y-intercept?
No. I was going to say an S. No, Y.
An X?
B.
B, there we go. Y equals mx plus b, that was our slope-intercept form. Where our y value is equal to the slope times x plus our y-intercept. Okay, so you know what you're looking for. We had difficulty putting it back into that general terms. Okay, if we're given our equation written in slope-intercept form, it's a lot easier to graph, isn't it? Okay. Sometimes we'll have that, sometimes we won't. So, let's look at example 1. In example 1, we're asked to solve the system of equations by graphing, and we are told that we have the equation y equals x. If I have y equals x, what is my slope? Yes?
1.
1. Okay? So that means that for each unit I go up, I go over 1, correct? Alright. What's my y-intercept? 0. Good, so it's going to go through the origin. So I'm going to go ahead and put a point at the origin. up 1 over 1, down 1, left 1, and I'll go ahead and create that line. Okay? We want to make sure that we label the lines that we graph. And this is y equals x. Okay? The second equation that I'm given in example 1 has y equals negative 3x plus 4. If I'm looking to graph y equals negative 3x plus 4, what is my y-intercept?
Negative 3.
Double check. So I'm going to put my point at 0, 4. Okay. What is my slope? Negative 3. So if that's negative 3, what does that tell me to do?
Go down.
Go down how many?
3.
And I go over how many?
1.
1. Because it's negative, I'm moving in a downwards direction. Because it's a whole number, I have a denominator of 1. Says that my run, or the change in my x value, is going to be 1. So I go down 3, 1, 2, 3, over 1. Oh, look, we already have that point. Let me go ahead and add another just to make sure. 1, 2, 3, over 1. Here we go. And I'm going to go ahead and continue that line just to make sure. So your graph should have something similar to mine. Correct? All right. Where do these two lines intersect? What point do they intersect at? At 1, 1? So that means that my solution is the point 1, 1. Questions? Questions? Do we need another? Okay. Was I going to do another one anyway? Uh-huh. Alright guys, I want us to go ahead and skip to example 3, please. In example 3, I'm sorry?
You're trying to steal my phone. Literally, I found my phone. Come out my pocket.
I ain't even reaching his pocket.
Gentlemen, add some distance between the desks. In example 3, we're given the equations y equals x minus 2 Is this written in slope-intercept form?
No?
Is y equals x minus 2 written in slope-intercept form?
Yes.
Yes, it is. So my slope is What's my slope? 1. What's my y-intercept?
Negative 2.
Negative what?
-2.
Negative 2, thank you. Alright. My other equation that I'm given is x plus 3y equals 6. Okay? Is that written in slope-intercept form? No. So what do I need to do to get that into slope-intercept form? Subtract x. That leaves us with 3y equals, I'm going to go with negative x plus 6. Then what do I need to do? Almost. Does 3y work? No, 3y doesn't work. So what do I have to do? Divide by 3. When we divide by 3, we're left with y. Negative x divided by 3 is negative 1/3 x. 6 divided by 3 is 2. So, what's my slope? Negative 1/3. What's my y-intercept? 2. Going back to our graph, I'm going to add multiple colors on the same graph. Okay. Where is my y-intercept again? 2. So I need a point at 0, 2. My slope tells me that I need to do what?
Go up 1/3 and ever 1/3.
Am I going up?
Go down.
Okay, I'm going to go down how many? Down 1 and over how many?
3.
1, 2, 3. There we go. Do you want to continue that again, or do you want to go up into quadrant 2? You want to go to quadrant 2? Okay. So with our negative slope, then if we go up 1, we need to go to the left 4. I'm sorry, 3. 1, 2, 3, because we're working with 1/3, not 1/4. And then we're going to go ahead and we'll graph that line. There we go. This is x plus 3y equals 6. Alright, what's my other slope? For my first equation, what was my slope? One. What's my y-intercept?
Negative 2.
Negative 2. So where do I put my first point? Where do I start? I'm going to start at y equals negative 2. And my slope of 1 tells me that I need to do what? Up 1 over 1. And I'm going to go down into quadrant 3. Down 1, left 1. And I'll go ahead and graph that line. Where do those two lines intersect? 3, 1. So what is my solution? Right, then my solution is 3, 1. Because the place where the two lines intersect, that is the solution. Questions? Let me ask you this. Do you think that all systems of equations will have a solution?
No.
You don't think so?
Mm-hmm.
So, why not?
Well, because
If they don't have all dots connecting sometimes, like there might not ever be a spot that will happen if like if it doesn't add up right or something like that.
Okay. So you think that they just might not ever intersect? Okay. Anybody agree or disagree with him? What? I didn't hear you. What?
I disagree.
You disagree?
Unless they're parallel, they're always going to intersect.
So I have someone saying that they disagree unless the two
what
lines
he means.
would be parallel. Okay. Anybody else?
What was the question?
Will every systems of equations, so will every set of two equations have a solution? You're going to say probably not. Do you have support your decision?
Like what he said, like two lines can be parallel.
Okay.
There's more than one version.
For a solution to exist, do they have to be possible on the coordinate plane that we graph? So what if we had two lines, they're not parallel, but they don't intersect on the coordinate plane that we have?
They'll intersect.
So you say what?
They'll intersect eventually.
You think they'll intersect eventually? Okay. Anybody else? No. Is it possible to end up with a situation where you graph the same line twice?
yes.
Yeah. How many solutions would be possible then? Infinite. If you end up graphing the same line twice, you have infinite solutions. And that's what you would write as your solution. Infinitely many solutions. Okay. Before we move on and look at another example, are there any questions about what we've discussed? Okay. How would we know that two lines are parallel?
They're approaching going in.
Okay.
Because
Is-
there's two lines.
All right.
Opposite.
Hold on. Is there a way? Is there a way to determine that without graphing?
Your eyes.
What?
Your eyes.
If they don't get closer, they're parallel.
See?
I'm sorry?
If they don't get closer, they're parallel.
Okay. Without plotting the lines on the graph.
Let's just say you have one line on the graph, and you would not know if there's.
Oh, if the slope is 0.
I
Or you
disagree.
can just look. Like, see,
That-
that little
that-
metal bar, those two metal bars will never touch if they go parallel.
It's a slope.
So they'll never ever touch.
Hold on. Hold on. What did you think?
I said if like how much the x goes up each time you plot another point, and the same for the y goes up.
Okay, so what do we call it? What do we call that relationship between the x and the y?
Variables.
It is represented by one of these variables.
Like terms?
Okay. one of the variables in our slope-intercept form equation can tell us if they will be parallel or not. Does the y-intercept have anything to do with lines being parallel?
No.
No.
The x-intercept.
The x-intercept isn't given to us in our equation.
Huh.
The line, if the lines don't, hold on. Guys, this is deeper level thinking, okay? So stay with me.
Use your old Twitter.
If we have two parallel lines on this graph, correct? One's blue, one's pink. They have the same slope. So, can I say then that if two lines have the same slope but a different y-intersect, that they're parallel?
Yes.
Yeah. Because the slope says we're going to keep going up and over the same amount every time, right?
Yeah.
So if we are doing that at the same amount every time, are they ever going to touch?
No.
No. So if the slope is the same, how many solutions would we have?
6. Infinite.
0 solutions. Because if the lines will never intersect, we will never have a solution.
So wait, I was right?
No, you're way off.
I'm talking about the first question when you said can there not be an solution?
Correct. In the question, will there always be a solution? You said no. That part was correct.
Oof.
Because it is possible to have equations that are parallel to each other. And if in doubt, graph. But if the slope is the same and the y-intercepts are different, then that's another way of determining that they're parallel. So there is no solution. Okay? Questions? Would you like to see one more before we go on?
I think we're good.
Okay. Thank you very much.